Hello and welcome to Secure Code Warrior. In this module, we'll be discussing the potential dangers of using AI to write code. We'll look at what to be aware of and explore several examples. We're all familiar with the remarkable benefits that AI brings to the table. It allows us to write code more swiftly and efficiently and speed up development processes. However, it's important to acknowledge that when it comes to using AI for code generation, there are several significant dangers we need to be aware of. Let's look briefly at each one. 1. Sharing sensitive code. Copy-pasting or sending sensitive code to the AI API can be extremely risky. Depending on the terms of service, the submitted code may become integrated into the training model, potentially leading to the leakage of sensitive information and compromising security and confidentiality. 2. Insecure or outdated code. Relying solely on AI-generated code can result in insecure software. AI models learn from the data they are trained on, including any flaws or errors present in the training set. If the training data contains suboptimal or incorrect code, the AI may replicate those mistakes. 3. Hallucinations. AI models trained on vast amounts of text data can sometimes generate code that seems plausible but is flawed or insecure. These hallucinations can lead to serious vulnerabilities in the code. 4. Reinforcement of biases. AI models are trained on existing data, and if the training data is biased or contains unfair practices, the generated code may reflect those biases. This can perpetuate discriminatory or unethical practices in the code base. 5. Lack of contextual understanding. AI models may struggle to grasp the full context and intent of a coding task. As a result, they may generate incorrect or incomplete code that does not fully align with the programmer's intentions. 6. Dependency and loss of skills. Over-reliance on AI-generated code can lead to a decline in programming skills among developers. Dependency on AI for code generation may reduce the ability to understand and debug code, resulting in a loss of human expertise. Danger 1. Sharing sensitive code. Copy-pasting or sending sensitive code such as access tokens, passwords, or proprietary algorithms to the AI API introduces potential risks. Depending on the terms and services of the AI service, if the model stores and trains on the provided user input, the model could leak this sensitive data to other users. Let's look at an example. A team of developers at a cutting-edge technology company is working diligently on a groundbreaking proprietary algorithm. A developer on the team is entrusted with the optimization of this algorithm. They decide to leverage an AI assistant to aid in improving the algorithm's efficiency. Unbeknownst to the technology company and the development team, an outsider using the AI requests code that is related to the proprietary algorithm. As this cutting-edge proprietary algorithm is now part of the AI learning data, it provides the outsider with code that closely resembles the proprietary algorithm. The AI does not understand this is sensitive data and a potential high-risk misuse of information. The outsider gains unauthorized access to the valuable intellectual property that was meant to remain confidential. Danger 2. Insecure or outdated code. Relying solely on AI-generated code overlooks the need for human oversight and thorough code reviews. Writing secure code requires a deep understanding of the specific application, potential vulnerabilities, and countermeasures. Additionally, it's essential to note that AI models are trained on historical data. This means that the code samples you receive might not be up to date or may be insecure from the start. Technology and security practices evolve rapidly, and what was considered secure in the past may no longer be sufficient. relying solely on AI-generated code without considering the latest security standards can leave your software exposed to vulnerabilities. Lastly, the models could directly or indirectly use malicious data samples, for example via indirect prompt injection threats, which involve attackers embedding malicious code in non-readable forms in training data. For instance, attackers might hide the code by setting the font size to 0 or making it blend with the background color. Although users may not detect the presence of this malicious code, the AI model still uses it and might incorporate it into the generated code. Let's look at an example. A developer requests a code snippet for implementing a login and sign-up feature from an AI model. The AI generates the code, but due to its limited context and knowledge, or for the sake of simplicity, it overlooks important security considerations. It focuses on creating the most basic version of the code for the purpose of explanation, omitting complex security measures that are necessary in a production environment. The generated code uses a suboptimal hashing algorithm to store the user's password. The AI was trained on historical data, unaware of more secure hashing algorithms available today. Additionally, a fixed value is used as the secret key to sign the access token. This is a serious security flaw as it makes the token predictable and vulnerable to attacks. When the code gets deployed into production, it becomes a prime target for hackers. A hacker can easily reverse engineer the fixed token and craft their own access tokens, gaining unauthorized access to user accounts and sensitive information. Danger 3. Hallucinations. AI models, although impressive, cannot guarantee the production of secure code. At times, the code that is produced might include mentions of libraries that don't exist. These non-existent references are referred to as hallucinations. The referencing of non-existent libraries by AI models poses a unique risk. Adversaries can exploit this situation by creating a multitude of libraries with names that could occur in AI-generated code that contain malicious code. Developers may unwittingly use these non-existent libraries, which could lead to the exposure of sensitive data, installing malicious code such as backdoors, reverse shells, and more. Here's an example. An attacker begins by registering a few package names that appear simple but closely related to logging, such as Logger, Logify, and SmartLog. These packages, however, do not exist yet. The packages will contain malicious code that, upon installation, executes code that takes the environment variables of the user and sends them to a server controlled by the attacker. Meanwhile, the developer seeking a code example around logging in their language of choice turns to AI for assistance. The AI processes the developer's request and generates code examples. However, due to the nature of AI package hallucination, there is a chance that it may suggest a package name that is made up, but that the attacker has utilized to create a malicious library. Unaware of the nefarious intent, the developer decides to proceed and installs and implements the malicious library. Installing this library triggers the malicious code that the attacker has implemented, and the sensitive environment data is sent to the attacker's server. The attacker closely monitors the situation, knowing that the unsuspecting developer has unknowingly imported the fake logging library. The attacker's goal is to use the stolen sensitive information to gain unauthorized access or carry out malicious activities. Danger 4. Reinforcement of biases. AI models rely heavily on the data they are trained on. However, if the training data itself is biased or contains unfair practices, the generated code can unwittingly perpetuate and amplify those biases. This means that if the training data is skewed towards a certain demographic, the AI-generated code may reflect discriminatory or unethical practices, further entrenching these biases within the code base. This poses a significant risk to the accessibility, fairness, inclusivity, and social justice in the software industry, as the biases present in the training data can inadvertently seep into the very fabric of the code. Here's an example of how that might happen. A developer requests a code snippet for a user registration HTML form. The AI generates the code, but unfortunately, it includes terms and design choices that are biased and not inclusive. In the generated code, the terminology used includes the term whitelist instead of allow list. The term whitelist is biased as it implies a preference for certain groups or individuals. In modern times, inclusivity should be considered when developing code. The form asks for the user's gender and provides only male and female options. This binary approach fails to account for the full spectrum of gender identities and can make individuals who don't identify strictly as male or female feel excluded. Additionally, the code provided by the AI model has been simplified and lacks support for screen readers. This excludes individuals who rely on this assistive technology to navigate digital content. The impact of biased and exclusionary code can be far-reaching. It reinforces societal norms, perpetuates stereotypes, and fails to respect the diversity of human experiences. Danger 5. Lack of contextual understanding. One of the challenges faced by AI models in coding is their struggle to grasp the full context and intent of a given coding task. While AI is highly proficient at pattern recognition and generating code snippets, it often falls short when it comes to comprehending broader objectives. AI often only satisfies the request, which can cause the generated code to be incorrect or incomplete. Without a comprehensive understanding of the context, AI models may overlook vital nuances or make faulty assumptions, leading to suboptimal or non-functional code. Let's look at an example. A developer wants to implement a bonus points feature for their platform. They use an AI to provide the code for this feature. The AI generates a code snippet, offering bonus points to users for successfully inviting others to join the platform. It assumes that users are unique and restricted to having only one account. However, unknown to the AI, the platform the developer is working on doesn't have this unique requirement. Users can create multiple accounts, allowing for potential exploitation. Sensing an opportunity, an attacker discovers the vulnerability arising from the AI's lack of context understanding. Exploiting this oversight, the attacker takes advantage of the lack of unique user requirements by automating the creation of multiple accounts and the invitation process, accumulating an excessive number of bonus points. Then, the platform suddenly starts receiving requests for high bonus point payouts. Danger 6. Dependency and loss of skills. Lastly, the convenience and efficiency offered by AI-generated code can lead to an over-reliance on automated solutions, potentially resulting in a decline in programming skills among developers. When programmers become too reliant on AI for code generation, their ability to understand and debug code may diminish over time. This dependence on AI may lead to a loss of human expertise, as developers may become less adept at identifying and resolving issues within code. Consequently, the software development process may suffer from a lack of critical thinking, problem-solving, and innovation that human programmers bring to the table. It is essential to strike a balance between leveraging AI as a tool and maintaining the proficiency and knowledge of human programmers to ensure a holistic, robust, and safe approach to coding. Here's an example. A developer notices a significant productivity boost when they start using AI-generated code to expedite the development of new features that are piled up in their backlog. Impressed by the convenience and efficiency offered by the AI-generated code, the developer starts relying more and more on it to generate code without actively learning, questioning, or critically evaluating the output. As time goes by, the developer finds themselves becoming less knowledgeable about the codebase since they haven't personally written a substantial part of it. Furthermore, the codebase becomes increasingly disorganized and plagued with extensive code duplication. Now faced with the critical bug received through customer feedback, the impact of the disorganized codebase and the developer's diminished programming skills become apparent. As the AI's contextual limitations hinder its ability to provide effective assistance to locate and fix the bug, the developer, now frantic, spends considerable time and effort grappling with the disorganized codebase. Conclusion: be aware of the dangers of using AI to write code. While AI and similar technologies have incredible potential, as developers, we must use them responsibly. The risks associated with using AI-generated code for security-critical applications cannot be ignored. It's essential to exercise caution, have human oversight, and thoroughly review the code to ensure its security and reliability. Also be mindful that some AI tools may generate code with potential copyright concerns. Congratulations, you have now completed this module.